Hey YouTube, today we want to take a look at how screws work. I'm going to do a follow-up video on how to use a screwdriver, but I thought before we actually talk about how to use a screwdriver, we should understand what a screw is and how it actually works and how it actually gives some mechanical advantage over just something without threads. So let's get to it. Let's see how a screw actually works. I'm going to use this bolt as the example, and then I'm going to show some stuff with these two little screws down here after, okay? But just to demonstrate a bolt as a screw, it has a shaft, it has a head that you have some sort of mechanical device that would actually offer up some torque. In this case it would be a wrench. In the case of a screw like this, it'll be a screwdriver. There's a shaft with threads, and hopefully you can see the threads in the video, and the distance between each thread is called a pitch. Utilizing these screws that we have as examples, they're both the same length. This one has a finer pitch, meaning the distance between each thread is much smaller, much less than the distance between these, which this one would have a coarser pitch. In its most basic form, a screw is a mechanical device or a mechanical tool that allows you to move a load represented by this knot from one place to another. So if you take the knot and you run it up the shaft of the bolt or the screw threads, it moves from the bottom of the bolt, and it could move all the way to the top. And if you have material in between the two, when you start running this up, it'll exert force, which is why you could use screws to actually fasten items to one another. So like if you had two pieces of metal in between the two and you screw this up, the force between this two will cause the pieces of metal to hold together, to bind together, to fasten together. But how does that actually happen, and how does that actually work? Let's take a look at the threads of a screw and we'll try to figure this out. Let's take, for example, a parking deck where you have a spiral ramp to move cars up and down into the parking deck. If the cars were to go vertical, it'll take a lot of force and a lot of effort to try to get the car to move up a ramp vertically. But if the ramp goes spiral, right, the cars could go up a much gentler incline. And let me demonstrate what I mean by that, okay? We're gonna use these two screws, the fine thread one and the coarse thread one, both of them 2-inch screws, to demonstrate what I mean. If we take a piece of string and wrap it around the threads of the fine threaded one, I try not to miss any threads, where I've missed one down there. If we expand this out, we see that the total run of the threads on this 2-inch screw is roughly 11 inches. So for a 2-inch screw, we're trying to move a load up a slope that kind of resembles this. Now let's try it with the coarse one. We pull this apart now. For the same 2-inch screw, we see that the run is much steeper. Much steeper. And it resembles something like this one. So for the same two screws, we could move, if we had a constant load, we could move it up this one, or we could move it up this one. The gentler slope means you could exert less force to move the same load, or use the same force and move a bigger load up the gentler slope than the steeper slope. What that means is, for a screw with a finer pitch, granted that the material could hold the tension and all that, you could tighten this one down more than you potentially could tighten the coarse thread one down. Which is why when you drive a screw in that is a fine pitch screw, you could exert a lot more force in between two pieces of material than if you use one that is coarse thread or very coarse thread. If you're talking about using a bolt, if you have a fine thread bolt with a nut, means that you could exert a whole lot more force on material that goes in between the nut and the bolt, or in terms of the screw, in between the material that the screw is going into and the head of the screw. So you could tighten this thing down as tight as either the material in between could take, or the torque settings, or the torque properties on the bolt before it actually shears out. This is what makes the bolt suitable for, like in jacks for lifting cars, or items where you need a mechanical advantage. Coupled with the torque that you put on this, which I'll explain in the next video, you could actually lift, move, or tighten things down tremendously tight, or lift tremendously heavy items like a car going around a spiral ramp, versus if you try to move things vertically in one plane. I hope this video helps understand how a screw works. It mightn't be the clearest thing in the world, but I hope it does give a little bit of clarity. If you like it, please give a thumbs up, subscribe, and we'll see you on the next one. God bless.